we're here with Yunso on reviewing the design of the cold saw.
Yep.
And the initial design we start with, so here's how it's looking towards the end of the day. Show the whole thing. Yep, so a cold saw like this. We've got an assembly of a base plate.
The base assembly.
Base assembly, and we've got then above that, what do you call that?
A swivel
plate.
Yeah.
Above that is a mounting plate for the vise.
That's correct. So we can actually go over this step by step.
Yep.
seeing
But
the
let's
different
show the
assemblies.
previous version. So in
The
the previous version,
we wanted the swivel mechanism to, in the previous version, have a base plate here. This is a front view. That would be the front of the base plate, this. And then this was to be mounted on into the base plate, such that this and the base plate would be one. This is a flanged, round, very thin round bar. And then you would have a large hole. Now this is a top view of the swivel plate. You would drill a large hole like this, and then fit the swivel plate onto the base plate, then put the flange disc on top of it, then screw it down, and such that this plate would be able to swivel around the flange disc. So after,
so here we have the flange disc analogy, and the new version will now be this mounting plate replaces the flange, and this swivel disc somewhat replaces the, well,
yes,
the bolt replaces the other part.
Yes,
But,
we have a threaded
okay, so
rod.
this is a simplified assembly. So let's just go through that. Let's go through this design here.
Within the assemblies or within the full assembly?
Within assemblies.
Okay, within the assemblies. Alright, so starting from the base assembly, where the cold saw contacts the mounting surface, you have these 4 blocks as spacers welded onto the base plate, and then you have on the base plate the hole which allows you to put the swivel threaded rod into, such that you can swivel this, such that the rod is fixed relative to the base plate, and you swivel the base plate around that fulcrum. And then you have this flat bar, very thick, up here, spaced from the base plate, such that we have space for the swivel plate between here and here. And then this felt bar just acts as an elevated platform on which to mount the vise. And you see those 4 holes here, 1, 2, 3, 4, and those are used to mount the vise accurately. And that's.
Can you turn the light up on the screen a little bit?
Light up on the screen. Oh, I think this is maximum.
It's max.
Yes.
Okay.
Yeah, this is maximum.
Okay. Okay, so that's the base plate and mount plate for the vise.
Then moving on, we can see the vise assembly. So onto those 4 holes from before, you have these 4 fasteners.
Going through the body of with recessed holes.
Yes. And then you have the counterbores up here, so you don't, so that the heads of these fasteners don't meddle around with the working surface, mounting surface. And then you have the moving blocks, one with the left-handed nut and right-handed nut, such that when you rotate this handle, the 2 blocks either move close together into the fixed block or move both away from the fixed block, such that we have the auto-centering vise feature. And another major feature is we have these adjustable, removable vise jaws that allow you to accommodate a variety of workpiece dimensions, because we don't have a lot of movement, but we don't have to if we have adjustable vise jaws. And these have 2 slots, one to fit the diameter of the screw, one to fit the diameter of the head of the fastener, and the fastener goes in through here to these weldments, these blocks that are welded to the moving blocks. And that's pretty much it. Like, if you want to cut thinner pieces of metal, you just unscrew these fasteners slightly and move all these adjustable vise jaws inwards, closer to the center, such that the thin material that you're working with is supported more during the cut operation. And other than that, shaft collars to hold the threaded rods and supporting shafts in place, and thrust washers for the threaded rod, such that we minimize the friction when clamping.
Okay.
And that's it for the vise.
And you can take off the vise jaws if you got
Yes.
thicker pieces, actually.
Yes.
And what's the maximum thickness that can fit?
Maximum thickness it can fit is likely 4.5 inches.
And without the jaws, that's 4.5, or with the jaws in place?
With the jaws in place, no, without the jaws in place, I'd say maximum is 4.5.
And
with the jaws, actually, I haven't really tested it. We can test it now, in fact.
We need to have 4 for with the jaws, probably.
If we can measure this,
for like 4x4 tubing.
Do the measurement now. Oh, let me just clear the selections because it's selected multiple faces. So it's 117. This is over 4 inches.
Okay, good.
So this is like 4.5 inches, even with the jaws already.
Okay,
so that's good.
Good.
And
okay,
moving on from the vice assembly
to the swivel.
One. And now, as discussed before, we had the swivel plate with the hole near the one edge, centered along the width. And in that hole, we're going to weld a threaded rod from above here. And then, such that we can fit this threaded rod into that hole from the base plate before. Other than that, we have on the swivel plate 2 shaft blocks which bear the load of this round bar, which is going to be supporting the drive assembly and the support for that, which will be heavy. So that's why we need pretty large diameter round bar. And
1.5 inch we're using.
1 and a quarter inch.
1 1/4.
Yes. But we're keeping the support very close to the shaft blocks, such that we get minimal deflection of the round bar. So that's one of the design rationales that are very important. We want to keep the support close to the shaft blocks. And the extra feature of this shaft block is you have a whole counterboard threaded such that you can put a screw into it, and I'll explain the functionality of this right now. It's called an adjustment screw that acts as a stopper for the movement of the drive assembly. When you hold the operation handle and then move the blade down, then you want the blade to not cut the vise also, right? You don't want the blade to keep on going down and cut into everything, including the base plate. So if you want the blade to stop at a certain point, bottoming out at a certain point, you need to stop the drive assembly with some kind of stopper. Mechanical stoppers are very effective because it's pretty much failure proof as long as you have the appropriate supports underneath.
Excellent. So now
now we can go to the support assembly, and this is what fits onto that round bar we saw before. That was supported by the shaft blocks. As you can see, we have thrust washers and shaft collars. Now, there's a special thing about these shaft collars because at the side you have these extra holes that allow you to put actual forces and essentially achieve tension, lining, say, this plate directly up with the shaft block through this thrust washer, such that that is very much in tension with the shaft block that's right next to it here. And if so, we achieve greater precision that way because we don't have any wobbliness. And other than that, you can see how this support assembly interacts with that stopper from before. As you rotate this along the axis of the supporting bar, that stopper will move into this screw will move into that stopper and contact the head of that stopper, and hence this entire assembly will have to stop. And this can be more effectively shown in the full
What's
assembly.
the thickness of that? That's 1/2 inch, or
it's right now 1/2 inch to maintain uniformity, but it can easily be changed, so it's not too much of a concern where things are easily editable.
Excellent.
Okay, and other than that, we have the feature of the modular drive assembly, where this support can be unfastened using these 4 screws, and this piece, which is supposed to mount the hydraulic motor and the blade guard, can just come right off, such that you can assemble this fully and then put it onto the support, making it easier to manufacture. Other than that, we have the operation handle, which can be attached on by welding. Very strong joint we need here, because it's going to handle a lot, and it's going to be transmitted over a long length. We have a lot of mechanical advantage to work around here. Beyond the support assembly, we have the drive assembly. Now, this was the hydraulic motor that's supposed to mount onto 4 holes of that drive plate that we saw before, and linked to it is a shaft coupling held